Floating 63 light-years from Earth is a world that wears a mask of perfect deception. Viewed through the cold eye of a space telescope, this distant sphere shines with a soft, azure glow, reminiscent of the deep oceans and gentle skies of our own home. Yet, beneath this tranquil, cobalt-blue facade lies a place of sheer, unimaginable violence. Here, the atmosphere does not nourish life, it shreds it. The rain is not water, but liquid glass, and it does not fall down, it screams sideways through the air at thousands of kilometers per hour. This is a planetary crucible where the laws of nature are pushed to their absolute limits. It is a world that challenges our understanding of what a planet can be, proving that in the deep expanse of the cosmos, the most beautiful objects can also be the most hostile. This planetary nightmare is catalogued as HD 189733b. It was discovered on October 5, 2005, by astronomers at the Haute-Provence Observatory in France. Located in the northern constellation of Vulpecula, the Little Fox, this planet was detected using the radial velocity method, measuring the subtle wobble of a parent star caused by the gravitational tug of an orbiting body. Because the orbit of HD 189733b is aligned so that it passes directly between its star and Earth, astronomers can watch it transit. Every 2.2 Earth days, the planet slips in front of its orange dwarf star, HD 189733, dimming the starlight by about 3%. This frequent transit makes HD 189733b one of the most studied exoplanets in the universe, serving as a Rosetta Stone for scientists seeking to understand the chemical compositions of alien worlds. Classified as a hot Jupiter, HD 189733b is a gas giant with a mass approximately 13% greater than Jupiter, though it is packed into a slightly larger volume. It orbits its host star at a blistering proximity of just 4.8 million kilometers. This is a mere 3% of the distance between the Earth and our Sun. At this extreme close range, the planet is tidally locked by gravity, meaning one side permanently faces the searing heat of the star, while the other side is cast in perpetual darkness. If you stood on the day side of this world, the orange star would fill most of the sky, burning with a fierce intensity. The temperature on this eternal day side reaches a scorching 930 degrees Celsius, a heat so intense that it would instantly melt aluminum. Surprisingly, the dark night side is not a frozen wasteland, it remains a sweltering 700 degrees Celsius. This relatively small temperature difference reveals a highly efficient global heat transport mechanism. Massive atmospheric winds, howling at speeds of up to 8,700 km per hour, transport the star's energy around the globe. This wind speed is more than 7 times the speed of sound, meaning any sound you try to make would be instantly torn apart by supersonic gales. The cobalt-blue color of the planet, which at first glance suggests oceans, is actually caused by these high-speed winds carrying silicate particles high into the atmosphere. The intense heat condenses these silicates into tiny grains of glass. As these glass particles catch the light, they scatter blue wavelengths, creating a deceptive blue hue. Driven by supersonic winds, the planet experiences a continuous, horizontal torrent of razor-sharp glass rain, cutting through the atmosphere with lethal velocity. While we have mapped its wind speeds and atmospheric composition, HD 189733b continues to present profound mysteries that challenge modern astrophysics. Chief among these is the rate at which the planet is actively evaporating. Because it orbits so close to its active parent star, HD 189733b is constantly bombarded by a torrent of high-energy X-rays and extreme ultraviolet radiation. Observations by space telescopes have revealed that this radiation is heating the planet's upper atmosphere to extreme temperatures, causing the gas to puff up and escape the planet's gravitational pull. Astronomers estimate that HD 189733b is losing between 1,000 and 100,000 tons of hydrogen gas every single second. This escaping gas forms a colossal, trailing plume behind the planet, resembling the tail of a giant cosmic comet. Scientists are currently debating the long-term fate of this world. Will the planet eventually be stripped entirely of its gas envelope, leaving behind a barren, rocky core? Or is its massive gravity strong enough to hold on to its core gases until the parent star reaches the end of its life? Additionally, there is the mystery of the planet's magnetic field. To sustain such powerful winds and protect its atmosphere from even faster erosion, the planet must possess a strong magnetic field, yet measuring its strength remains at the limit of our technology. The study of HD 189733b forces us to abandon our comfortable, Earth-centric view of the cosmos. Everything you have ever seen, experienced, or imagined on our gentle world is dwarfed by the sheer scale of the forces at play on this blue giant. It serves as a stark reminder that the universe does not conform to our expectations of beauty or habitability. The physical processes that create a stunning, sapphire jewel in the dark of space are the same forces that drive supersonic winds and horizontal glass rain. As our telescopes grow more powerful, peering deeper into the void, we will undoubtedly find more worlds like HD 189733b monsters dressed in the clothing of paradises. In studying them, we do not just learn about the limits of planetary physics, we begin to appreciate the fragile, extraordinary quiet of the home we inhabit.